Okay, let's do the 23rd second one. Okay, that is limit of the function when x is approaching 1, and the function is this one. Okay, so now when we take the number line, okay, now x is approaching 1, so let this point be 1. Now x is approaching from the right side towards 1 and from the left side towards 1. Okay, now 0, see, this is the number line, so 0 is here, somewhere here. Let's just assume 0 is this 0, this is 1, and so on, 2, 3, and this side minus 1, minus 2, so on. Okay, so now here the function says, the condition is if x is greater 0, this is the function. Okay, so greater 0 means this side, so this whole side greater than 0 of the number line, the function is 3x plus 1, 3x plus 1. Okay, so for the left hand limit, left hand side and the right hand side, you have a common function. Okay, the function is same for both sides. So now see, the position of x will be this distance, this length, okay, which we assume as h, and here also we assume the position of x as h, this length. Okay, so as x is moving from here towards the length of h, the length also decreases. Okay, in the same way, when x is moving from here towards 1, this h, the length will be decreasing, and as it reaches, x reaches to 0, to 1, this h, the value of h will become small and 0. Okay, so now when we find the limit, now see, we can assume, so the h becomes 0. Okay, we can assume that h is tending to 0, and here also h is tending, and will become 0. Okay, when x comes to 0, z comes to 1. Okay, now see, as x is approaching 1 from the left hand side, the left hand limit will be limit of the function as x approaches 1, as x approaches 1 from the left hand side, so 1 dash, okay, will be, which is equal to limit of the function f of, now instead of x, we will write x is equal to 1 minus h. Okay, and here instead of x we will write 1 plus h. 1 and plus h will give the position of x. 1 plus h is equal to x. Okay, so here in the left hand side, limit of the function as x approaches 1 from the left hand side is equal to limit of the function. Now instead of x we write 1 minus h. Okay, and h will be becoming 0, is tending to 0, which is equal to, now limit, now in the function we replace the value of x with 1 minus h. Okay, so it becomes 3 into 1 minus h plus 1 as h tends to 0. Now when we put the value of h in the function, we get 3, let's multiply 3. Okay, 3 into 1 becomes 3, minus 3 into h becomes 3h, plus 3 into 1 becomes 3. Limit h tends to 0. Okay, now when we put the value of h in the function, we get 3 minus 3 into 0 plus 3. Now this becomes 3 plus 3, which is equal to 3. No, 6. Okay, now again for the right hand limit, or HL, as x is approaching 1, the length of the h decreases and it becomes 0. Okay, so we write it as limit of the function f of x as x is approaching 1. Okay, x is approaching 1 from the right hand side, that is positive side, we mark it as 1 plus. Okay, is equal to, this is equal to limit of the function, instead of x we write 1 plus h. Okay, f of 1 plus h. Now as h tends to 0, h is becoming 0. Okay, which is equal to limit, now in the function instead of x we write 1 plus h. Okay, 3 1 plus h plus 1 as h tends to 0, which is equal to, now we multiply 3, limit h tends to 0, 3 plus 3h plus 3. Okay, now when we put the value of h in the function, we get 3 plus 3 into 0 plus 3. Again we get 3 plus 3, which is equal to 6. Okay, now here the LHL is equal to RHL. So we can say that, therefore limit of the function exists at x is equal to 1. Okay, at x is equal to 1. Okay, and that limit is, therefore that limit is, limit of the function as x approaches 1 is equal to 6. Okay, that's it. Now this x approaches 1 indicates both left and right. Okay, from approaching 1 from both left and right, because there is no mark here, dash or plus. Now see here, dash indicates it's approaching from left side, and here plus indicates it is approaching from right side. Okay, so this is the answer, limit. That's it.